All right, well, I hope everybody's having a good day. Just a couple things that I want to go ahead and let you know about. Remember, tomorrow your assignment over logic and truth tables is going to be due. Okay. If you want to retake the Intro to Sets quiz, I believe that's Tuesday morning. I'll have to check on the website to see when I set the deadline. But I will double check on that. We're going to have a quiz over logic and truth tables on Monday. Your exam is coming up a week from Monday on the 14th, so quite a bit happening tomorrow and the next couple of weeks. Hello. Hello. Thank you. Oh, both of them. Thank you, sir. Jacob. Oh, and sir. She is not here today. Thank you very much. Is it good?
Yeah, most of it.
All right. Glad to hear that. Okay, just a couple of other things. Remember, tomorrow, Friday, the first Friday in this new grading period. If this applies to you, if you happen to have failed an upper-level course the first 6 weeks and you need a waiver, then those are due to Mr. Young tomorrow. You can go ahead and pick one up from Mrs. Edwards at the back office. I think that's all I have, unless anybody has any questions. Okay, we talked about sets. Okay, we've started logic. We're continuing through that. We're going to work on implication today. I would like to go ahead and probably stop maybe about 15 minutes before the end of class and give you the opportunity to work on your assignment. I'm going to try to give you a little bit of time in class because that's due tomorrow. But the only other thing I have, you'll notice there was a gentleman with me when you came in today. This is Mr. George Yacht. He's a senior at Texas Tech University. And I will let you say a few words, sir.
Studying math and English at a secondary school. Each high school, so I'm going to be here on Thursdays, just watching class, which I'm still watching my kids. So I'll be moving in and out, so it's not standing next to you looking at your paper.
Okay. So we have the opportunity. There is a real college student here. Would anybody like to ask a question? Anybody thinking about anything? Appropriate.
Is it worth it?
Okay, so now are you talking about joining education or what?
College.
Okay, so Jacob asks, is college worth it?
Depends on what you want to do.
Jacob, what are you wanting to do?
I'm either looking into pre-med or psychology. So yeah.
For medicine, yes. I'd say college is pretty important. Yeah. I'm going to go to your doctor's office some years down the road, and I'll be looking at your certificate written in Sharpie on your wall. So.
And I'll print one out.
There you go. All right. Okay, anything else? Hey, John Henry. Okay. So the question was, why did you finish high school and decide you wanted to go back?
I didn't like high school, like a lot of people, for some reasons, but I also liked it for a lot of reasons. My coaches and my teachers did a lot for me when I was in high school, so I just want to do it for them.
Wow.
But mostly I'm just in it for the money.
Oh, that's why you get into education. I go home and roll in pennies every night. There you go, just rolling in pennies. Try to get that visual out of your head. Okay. All right. All right, so good. Let's go ahead and keep going. We are going to, wow, is it that bad, Ellen? I wish for death. Okay. But don't forget about the upcoming grades. The week after next is going to be kind of unusual. The week we actually have our test, what else is happening that week? It's on the 16th. Some of you know from Scholars. The PSAT is coming up. Now, for our class, it's really not going to affect us so much. We'll almost be able to continue as usual. Of course, my pre-calculus classes are going to be greatly affected by that. I did remember something I want to go ahead and mention. Tomorrow, during this class, in fact, we have a hold drill. Have you guys heard about that? No. It's going to be at 2:09. So that means basically a hold drill means that maybe something is happening in the hallway that they need room for. They don't want the students to see. Maybe a student has had some kind of seizure. There's a medical problem. I mean, there could be any number of problems in the hallway, but it's business as usual. So at 2:09, I'm sure that Mr. Anderson is going to make an announcement. I would imagine we wouldn't be in here very long, but this is the first hold drill we've had, so I don't know. So you are going to be missing just a short amount of 7th period. Just go ahead and let you know about that. Ellen.
In what situation would we need to be on hold instead of lockout or lockdown?
Well, my example was medical. What if a student fainted in the hallway? You know, I mean, they don't want 2,000 plus students going through. They need room. Or what if maybe there's a mess in the hallway or something, and I'm probably not coming up with the best examples, but something is happening in the hallway where we don't want students to be walking past that. Okay. So we're just going to hold, as they say. Yes.
I think a lot of us juniors are actually going to be taking the PSAT from what
I know that I know freshmen and sophomores are absolutely taking it, and then a few juniors if they signed up. Is that right?
If
Okay.
you got a qualifying score on the PSAT, they pay for it.
Oh, okay.
And so I think that there are a lot of us that are going.
How many people are taking the PSAT?
Uncle
They just
Brad.
Nice. Very nice. Okay.
Yeah, no lid.
All right. Okay. So before we go ahead and get started, anything else, guys? Sounds like a plan. Okay, so we're going to continue our discussion of logic. The past lesson, we introduced truth tables. We're going to go a little deeper into that with this lesson. We're going to bring up the idea of a tautology and a contradiction, basically verifying or falsifying a statement. But the two big items here are going to be implication and equivalence. So let's get right into it. Implication. These are the statements if P, then Q. Remember, we were talking about propositions, but here we have specific names for them. P is called the antecedent, while Q is called the consequent. All right. And an implication is formed when propositions P and Q are linked in the following ways. Typically, the way we're going to see it in here, IB, is going to be the if-then statements. But it could also be P only if Q, P is sufficient for Q, or Q is necessary for P. All right, so let's go ahead and run through a few of these, and then we'll talk about the behavior of implication, why its truth table looks the way it does. Okay, so example 1, write the implication statement using the propositions P and Q. All right, and you'll notice the notation here is going to be an arrow, P implying Q. A lot of times, I'm just going to go ahead and write it as the single arrow instead of doing that double arrow, which doesn't change anything. But we have the P, antecedent, John is not at work, Q, John is sick. Okay, so the implication, if John is not at work, then John is sick. Okay, well, let's try B. The antecedent, my watch is slow, and the consequent, I will be late. So what would that statement be? If my watch is slow, okay, then I will be late. Okay. All right, that's pretty easy. We're just writing the if-then statements given the antecedent and the consequent. Now, identify the antecedent and the consequent in the following implication statements. Okay, if a number is divisible by 10, then it ends in 0. Okay, so what's the antecedent? A number is divisible by 10. That's typically your if portion of it. So a number, I'm just going to go ahead and put the hashtag, that's the symbol for number, is divisible by 10. Okay, consequent, it ends in 0. There you go. It ends in 0. Oh, 0. Got that backwards. Okay, that's all there is to it. Easy, right? Okay. Love logic. Let's try this one. I will earn more money only if I work hard. What do you think the antecedent is? Okay, I might actually be switching it on this one. If it said, I will earn more money if I work hard, then I would go ahead and say that's the antecedent. But the one thing that's really sticking out to me right here is the only if. Only if that happens. Okay. But I'll go ahead and go with you guys. I mean, that's the one thing I need to talk to Mr. Reeves about. Mr. Yaw, what do you think about that? Would you agree? Would you go ahead and say the antecedent is I work hard or I will earn more money?
I work hard.
I think I would work hard. Okay. So if I work hard, okay, then I will earn more money. Yes.
I had a question.
Uh-huh.
Up at the top, when it has like the 4 bullet points that have the blanks,
Mhm.
and it's the order of them, the second one says P only if Q.
Oh, did I go right past that?
Has only if. You'd already filled it out.
Okay, so I was right.
Only if.
P only if Q. Yes. So that is correct. Only if, so I will earn more money. Ha-ha. P only if Q. Give it a happy dance. Okay. I thought that thing stuck out to me. I read it right at the beginning and I went right past it. Okay. So I will earn more money. No, I'm glad you said that. It's not often I get proved right. That's sad because I'm leading your education. Okay. I'll earn more money. I work hard. There we go. I knew there was something that was sticking out to me about that. Okay. Thank you, Reese. Thank you very much. Okay. Okay, what about C? The flowers will grow only if there is enough rain. Same as the last one. The flowers will grow. Okay. There is enough rain. Unless you're in Lubbock, Texas.
So if you have a statement that said I will earn more money if I work hard, not it excludes the only thing.
See, that's
which you
that. Yeah,
have-
that's what stood out to me. Then I would say the antecedent is I work hard.
Okay.
Okay. If I work hard, then I will earn more money. Yes, but I mean, I read those at the beginning. I just went right past that. So, thank you again, Reese. I really, it's cool. Okay. It is cool. It is cool. All right. Okay, so truth table for implication. Okay, complete the table. So here's the thing about implication. The antecedent and the consequent, you're only going to end up with a true result if they're both true, true, or false. So order really does matter when you're talking about implication. The only one that you have to be very careful about is the true-false scenario. That is the only one that's going to have a false outcome. So this has always been kind of difficult for students in past years to kind of wrap their heads around. So let me see if I can give you an example. All right, and I believe this is in your packet. If you look at the next page, did I put that in your packet? Okay, good. Implies doesn't mean suggests. Also, there's no causation with implication. So why does implication behave the way we see it in a truth table? All right, so I tried to think about this and try to explain it in such a way where it's going to make sense. So I've got this statement here. Consider the following. If your pet is a dog, then your pet is a mammal. Okay, so let's kind of run through all the scenarios that we have here. We'll take these one at a time. So let's say we really do have a dog as a pet. So that means the first part of this is what? It's true. Well, if your pet is a dog, then is your pet a mammal? Yes. So this is a true scenario. So that means it's a true statement, right? Okay. So that's taking care of that first one. But now let's go on to the next one. Suppose your pet is a cat. Okay. Well, if your pet is a cat, what does that mean for the first part? It's false. It's not a dog, it's a cat. But even if it's a cat, is it still a mammal? Yes. So this is that third scenario right here, where the first part could be false, but if the second is true, then it's a true statement. Okay. See, remember, we're going from the original statement, if your pet is a dog, then your pet is a mammal. Okay. But if my pet is a cat, then it's still a mammal. See, that's false according to this, and then true for the second part. Now, what's the third pet that we have here? Suppose your pet is a bird. Okay, so applying that to the original statement, okay, it's a bird, it's not a dog, so what does that mean? Okay, so if your pet is not a dog, if it's a bird, then is your pet a mammal? It's not a mammal. So in this case here, they're both false according to the original statement, but would it still be true? If your pet is not a dog, then your pet is not a mammal. Does that kind of make sense? Okay. It's the way you word these particular phrases. I know it can be kind of confusing in the beginning. Okay. But now here's the one that we need to be on the lookout for. The last one where the antecedent is true, but the consequent is false. Can a situation exist where your pet is a dog, where the first part is true, but not a mammal, where the second part's false? Is there any way that could possibly happen? Okay, no. So that's why we have the behavior the way we do. With implication, the only one you have to be careful of is the true-false. That's the only one that's false, but it has to be in that order. The antecedent has to be true, the consequent has to be false. Okay, I've got another example here.
Sorry. No, Amy said something.
Emmy, what'd you say? What?
She thought birds were mammals.
Okay, that's okay. Well, by definition, mammals do what? They give live birth, have hair, don't they produce milk?
All of those don't apply to birds.
That's true. That's true.
You're wrong.
That's true. Hey, you never know. Maybe she was just winging it. It's a bird.
Why you gotta dog us with these jokes?
I know that one's kind of rough, John Henry, but
Alright, go ahead with this children and get back.
all right. Sorry, I went off on a tangent there. It's a math joke. Tangent. Okay. All right. So let me give you another one of these. If a figure is a square, then the figure is a quadrilateral. Okay. So by definition, what makes a square a square?
Four even sides.
Yeah, we have a four-sided figure where all sides are congruent. Now, what does it mean if you're just labeling it as a quadrilateral?
Then it has 4 sides.
Then it simply has 4 sides. Okay, we don't have any further distinction on like the lengths of those sides. So it says, suppose you have a square. Okay, well then that would make this first part true. Okay, but then the figure is a quadrilateral. Well, a square is a quadrilateral, so that's true. This is the true behavior. Remember, what's the only one we have to be careful of? True, false. Okay, so we're going to get there. This next one is the false true. Suppose you have a trapezoid. Okay, so by definition, what's a trapezoid? I like Reese says that with her fingers. Okay, well, it is a quadrilateral where one pair of opposite sides are parallel. Okay, so suppose you have a trapezoid. Well, a trapezoid is not a square, so the first part would be false, but is a trapezoid a quadrilateral? Yes. Okay, so that's a true statement. Even though it's not a square, it is still a quadrilateral. Okay, well, suppose you have a triangle. Okay, Reese, show me a triangle. There you go. Okay, that's way better than the trapezoid you showed me. Okay, well, again, first part here, okay, a triangle is not a square, so the first part, the antecedent is false. Is a triangle a quadrilateral? Okay. If a figure is not a square, then it is not a quadrilateral. Well, if you have a triangle, that would be a true statement. Okay. The only one you have to be careful of is the true-false. Can a situation exist where you have a square, but it will not be classified as a quadrilateral? Okay, no, it's not possible. Okay, so if you're talking about implication, if the antecedent is true, but the consequent is false, the overall validity of that statement is false. Does that kind of help to make it a little better? Okay.
Can you explain how when both of them are false, how it can be true?
Well, because we have an example where this is false. Because think about just pushing the word not in here. If a figure is not a square, then it is not a quadrilateral. If you're dealing with a triangle, would that be a true statement? Yeah. It's not a square and it's not a quadrilateral. But because I'm dealing with a triangle, that would be a true statement. Okay, Ella?
Why can't you just add a word to the sentence?
Why couldn't you add a word to the
Why
sentence?
can't you just add?
Well, remember, all of this logic that we're talking about is related back to sets that we're referring to. So if I add that one word not, what's that equivalent to? What's the one thing we were doing with sets that had that little tick mark? Okay. The complement, negation. Okay. All of it's related.
So
Okay.
are you looking at the sentence as a whole then? So like
Yeah.
completely replace square with triangle and then
No, actually what I'm doing is I'm just negating it. Okay. Because think about what it's saying. If a figure is not a square, so any figure besides a square, then it is not a quadrilateral. All I did was negate each one of these. See, they're both false because what am I dealing with? A triangle. But could that statement describe a triangle? Yeah, so it's still true. I know when I was in college, I took logic, not for very long, because it didn't make sense to me. I'll be honest. It's kind of hard sometimes to wrap your head around this. I don't know, Mr. Yacht, is there another way that you think you could explain it?
I think that I see the first statement, the idea of a triangle, since that statement doesn't apply to the triangle, you can't prove it false. That's how
Oh,
I'm not sure
Okay.
if that's helpful.
because the way that I'm a little confused about it is
Uh-huh.
that if you do what you're talking about, if you negate it, you say if the figure, so like in the trapezoid one, you say if the figure is not a square, then the figure is a quadrilateral. But that's not necessarily true because there are a lot of shapes that are not squares that are also not quadrilaterals. And
Oh,
so,
yeah. Oh, yeah.
like,
It's just in this
my
case,
brain,
we're,
that doesn't
yeah,
make sense.
it's just in this case we're
If
being
you
very
don't
specific.
know for a fact that it is false, then
Mhm.
you're assuming that it's true.
Yes.
Okay.
So is that better?
Yes.
Okay. Good.
I'm still gonna have to think
Good.
about it.
Yeah, I mean, it still takes a little bit of time. Ethan?
So the true or false statement is dependent on whether or not P, whatever object that
Yes.
is the same as the objectable P. So like triangle is different than a square, so then that will make it.
Yes, because you have a different object. Yes, you're right. Mm-hmm. Okay. Guys okay? Okay, good. Yeah, here we go. Logic. Okay. So if I go back over here, just to finish this up, here's our behavior. So implication is related to, what does that mean, the sideways U?
Proper.
Okay, subset. Now I heard proper. Is it just a subset or is it a proper subset? That is a proper subset. Okay. Remember, subset has the line below it because a set cannot be a proper subset of itself. But if you have the bar, I always think of that in terms of equality. So the group can be a subset of itself. Okay. All right. And let's go ahead and do some examples, and then we'll get on to implication. Oh, well, it's 1:47. Let's at least go ahead and do this one, and then I'll go ahead and stop, let you work on your assignment like I said I would for today. Example 5. There was an example 4, but I tried that the first year, and it really didn't do anything but help to confuse students. So I just have since removed it from the lesson. Everybody still seems to be able to get the basic idea. So that's why it goes directly to number 5 here. So P, X is a multiple of 4 greater than 1 but less than 20. Q, X is an even number greater than 1 but less than 20. Write the truth sets P and Q for the propositions P and Q. Well, when it says truth set, what do you think they're wanting? Okay, what's that mean?
Those numbers that apply.
That's exactly right. You want to actually generate the set. Find the elements that are defined there. Okay, it's just another way of saying, basically what values are we going to have. So if I want the truth set for P, it's a multiple of 4 greater than 1 but less than 20. So what would be my first one? 4, 8, 16. Now, would I put 20? Because it says less than 20. Okay, so there was a lot of room there for 4 elements. That's okay. All right, so we got that. And then Q, it says X is an even number greater than 1, but less than 20. All right. 2, 4, 6. Who do we appreciate? You know, I work so hard at these. I really do.
Do you like just sit there and come up with what you're about to say for the lesson?
Sometimes I do try to think about them ahead of time if I don't think that the lesson is engaging enough. But sometimes I'm that talented. I'm that talented, yes, where I can be looking at a problem and be thinking, "Ooh, this would be funny to say."
All right.
Obviously, I'm correct. Okay. All right. Okay. All right, so B, state the implication, P implies Q. All right, so how would I change this into an implication? How would I start it out? If, I heard X, okay, is a, and I'm going to abbreviate some of these, is a multiple of 4 greater than 1 but less than 20, what? Then X is an even number. They're going to use hashtag. Greater than 1 but less than 20. There we go. Okay, so it says put the elements of P and Q in the Venn diagram to show the relationship. And that's really what we're trying to do here. We already told you that the implication P implies Q is related back to subsets. Okay, in that first lesson we had about a week ago. And then we're just trying to visualize this for you. So I know that a lot of people had a little bit of trouble with the Venn diagram the other day. Would anybody like to come on up and place these elements for me? Okay. Stephanie, you smiled as soon as I said that. You're still smiling. All right. I love it when somebody volunteers. Uh-huh.
So the ones that have in common, they go in Q.
Yes, because the way we have this, P is a subset of Q. Okay, just kind of think about the bigger picture. If P, then Q. Does that make sense?
But how's that going to help me put them?
Oh, no, no, I'm just talking about the overall logic. I'm sorry, no. I didn't mean to stop you.
And then just everything else is here.
Okay. There we go. I would just move one element.
Because 66. Oh, I didn't see that.
Okay, what do you guys think? That is correct. Okay. I'm sorry, what? Did we miss something?
Oh, I didn't It doesn't give you a universe, so you don't know.
Yeah, the only thing we know or what we have in these two sets, the universe isn't established for us. So yeah, that's as far as we can go. Okay. Because for a second I was like, what numbers are we missing here? Okay. Does that make sense? Okay. All right, so what I'm going to go ahead and do, I'm going to go ahead and stop it here. But let me go ahead and get out the assignment that's due tomorrow. Okay. Yeah, go real fast. Pass this right here. Okay. Hopefully you've had the opportunity to kind of look at the assignment. Is there any problem on the homework that you're having difficulty with? Let me go ahead and pull up logic and truth tables. I believe that's the key. Okay, well, it's thinking. It's not letting me do anything. Maybe I can. Nope, can't start it. I think for certain, like one or two people have finished the homework. Emmy, you finished, right? Okay. So is there any question on the assignment somebody's looking at and it's kind of difficult? Reese, number 6. Okay. All right. Yeah, no, so those are infinite. So x is a multiple of 5, 5, 10, 15, 20, and so forth. Q, x is a factor of 45. That's definitely a finite set. But then R, x is a square number. That is another infinite set. Okay, because it doesn't give you a boundary. I would love to pull this up, but it is... Oh, there it goes. Okay, let's try this again. Kind of got stuck. Okay. Okay, I may just have to write this problem out because for some reason this notebook file is not wanting to load. It would be so much easier if I had the snapshot, but let's see what happens here. Okay, so well, oh, there it goes, finally. Okay. Okay, here we go. So now I don't have to write the whole thing out. That's better. Okay, so P, x is a multiple of 5, Q, x is a factor of 45, R, x is a square number. So A, write a sentence in words for this statement. Okay, so kind of walk me through this. What is this symbol right here, the V? Okay, that's the union, that's or, that's the key word there. What about this one? The intersection, the sideways L? Not, okay, that's the negation. Remember also you can see the little curvy tilde symbol. All right. So who would like to come on up using those 3 propositions? Write a sentence to express that. Ethan, you want to do it? Okay, come on up. Okay, so x is a multiple of 5 or okay. Oh, now remember, look at the first part. It's P or what?
P or R. Did I write it down? Oh, okay, yeah.
There we go. Okay. It's okay. So x is a multiple of 5 or x is a square number. And x is a factor of 45. Okay. What do you guys think? Now, I would say that the frame is good. There's just one little detail. Is not a factor of 45.
Not.
That's fine. You're good.
It's not.
Yeah. So we know what you're trying to say. Okay, there we go. It's in English class. Okay. All right, so good. X is a multiple of 5, or x is a square number, and x is not a factor of 45. Okay. Would anybody want to share another version of that sentence that they have? Would you change it in any way? No? Okay. Well, we want to create a Venn diagram that represents the truth sets of those. Okay. So anybody want to help me out with that? Okay, maybe I'll go ahead and get the framework down. Now, we're not actually plugging the terms in. For one thing, we can't do that because two of them are what? Infinite, but I can still represent the group, with a circle. So what I had done, I said this was P, this was Q, and then I said this was R right here. And I used capital but lowercase. That's fine. Okay. So basically, what part of this Venn diagram would I shade to represent this statement? Anybody want to help me out? Anybody? We're shading this statement right here. The statement that we just wrote this sentence on. The P union R and not Q. Ellie, you want to try it? Okay. Okay. What do you guys think? That is perfect. That is exactly right. Okay. Do we need to elaborate? Yeah, here, yeah, you're just trying to visualize this, but it just makes it a little more difficult. It doesn't really kind of make sense because we have, for the first time, infinite sets. Okay. But nobody wants me to elaborate on that? Everybody would have gotten the same thing? Okay. And all we got left for number 6C is to complete the truth table for that statement. Okay. Now, who asked me about this question originally? Was that Reese? Reese, would you like to come on up and show me the truth table? Okay. Well, that's okay. You can put them to the side. You don't have to stack them all on top of each other. So what was the behavior for the union? It was one or the other. This one was or both. Okay. Is that the inclusive or the exclusive? That's the inclusive. The exclusive didn't allow both. Okay. So she says true, 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 false, true, false. Okay. So I'd say the 6th and the 8th rows are the only ones false. I'd agree with that. Now, not Q. Remember, this is just the negation, right? So false, false, true, true, false, false, true, true. Okay. What's that second one? Is that a true or a false? Okay. Then she says true, true, false, false, true, false. There you go. I would agree. That's exactly what I got. Oh, let's leave it there. That's fine. There you go. Yeah, that last one at the very bottom, that is a false. Okay, false, false, true, true, false, false, true, false. Okay. Now, this last one right here, let me go ahead and highlight this one. You said this one was the inclusive union. What's this? That started with an I. What is it? That's the intersection. What's its behavior? It can only be true if they are both true, one and the other. Okay, if only one is true or they're both false, it's got to be a false. Okay. Reese, what was it about that question that was giving you difficulty?
It was the infinite.
Oh, okay. Okay. All right. Is there anything else? Do 7? Sure. Okay. So let's take a look at this one right here. Note the or is exclusive. So that means one or the other, but what? But not both. Okay. So for this first one here, I do have 3 propositions, but I'm only exclusively looking at P and Q. All right. So one or the other, but not both. So true, true. That would be a false. Okay, so true, true. That's a false. True, false. That's true. What about true, false? True. It was the same thing. False, true. True. False, true. False, false. False. And what about false, false? Okay. Would everybody agree? All right. Now, what am I doing in this next column? Okay, I'm negating it. Okay, not the exclusive union. So it would be true, true, false, 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 true, true. Okay. Now for the last one, I want to go ahead and take this column that we just filled in, and I want to go ahead and take the union with R. Okay. So this guy right here. So I want to compare the 3rd and the 5th columns. But this one's the inclusive, so what does that mean? It can be both. As long as one is true, it's true. Both is true is okay. All right. So Matthew, could you help me out with this one? What would true, true give me? True. Okay. And what about a false true? True. And true, false? True. What about a false, false? False. True, false? False, false? True, 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 and false, true. You know what I keep thinking of when we go through that? Do you remember those commercials near the beginning of the year? Free, 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 free. Probably one of those things that you forgot about. You were happy to forget it until I reminded you of it. There you go. Oh, you're welcome. You're welcome. Okay. Don't forget about my going home and rolling in pennies. There's that image again. All right. Questions. Okay. Now remember, the hold isn't until tomorrow. All right. So this will be due tomorrow. We'll come in, start off with any questions. We have another focus activity, and we will continue implication. Remember, we have a quiz over logic and truth tables on Monday. Okay. All right. Okay.